In this video, we will demonstrate how to use Auto Side-by-Side within Vertex AI to evaluate the Gemini model against another LLM. This practical guide will show you each step in setting up and running an evaluation using the tools provided by Google Cloud Platform. By the end of this video, you'll understand how to navigate the Auto Side-by-Side tool, set up your evaluation datasets, and interpret the results from the Auto Side-by-Side comparative analysis. This will equip you with the skills to effectively assess the performance of generative AI models. Now, let's get to the demo. The link to this tutorial is provided so you can run the evaluation yourself. In this demo, we will be going over how to use Auto Side-by-Side to evaluate and compare the performance of large language models. To begin, we will first install the following package by running this command. We will be using this package to call the API from Google Cloud. After you run the command, make sure that you restart the runtime in order to use the newly installed package. A cell has been provided for the user to restart the runtime. After successfully running the cell, you will receive a pop-up indicating that the kernel has died and will automatically restart. Now, let us set up the necessary components. We will first create a Google Cloud account. In the account generation, it will prompt for your Gmail and password. Once you have created the account, you will be greeted with a screen similar to this. Open the menu tab on the left and select Billing. From there, you will have to enable billing. You would have to input a credit or debit card in order to activate billing, but there will be $300 worth of credit provided to you, so don't worry about it. Afterwards, you will open the menu tab again and select APIs and Services. Click on the library and search Vertex AI API. You will then click on Enable to enable the API to be used. Next, you will create a project in Google Cloud. Click on the drop-down menu on the top left and select New Project. From there, Google will guide you on creating the first project. Lastly, open the menu tab again and select IAM and Admin. You will see the newly created project. Click Grant Access and in the principal input the name of the principal of your created project, and in the roles drop-down, search in the filter Object. Here you will see the option for Environment and Storage Object Administrator. Add this to the principal and save. This is how it should look like with the role having a Storage Object Admin. Now we are ready to go. Since we are working on Vertex AI Workbench, you do not need to perform any additional steps. To begin, we will set the project ID. You can find the project ID by going back to the project dropdown and find the column where it displays ID. In this case, this is the ID for the project. Run the cell after you have changed the ID to your project ID. Next, we will set the region. In this demo, the region is set to US Central 1. Now, run the cell block. Now, we will generate a random UUID. This will be used to uniquely identify the project and avoid potential name collisions. We will now use the UUID to create a unique bucket URI name. Now we will move on to setting up the process. We will first import the libraries and define our constants. We will also define our helpers. Next, we will initialize the Vertex AI SDK by providing our project ID, region, and our bucket URI. As we have defined in our constants, we will be comparing a Gemini dataset with another LLM, one producing response A and the other response B. Each row of the data contains an ID and a document to summarize, and the two versions of the response to the document are also there. We can get a peek at this by using pandas to read the JSON and format it. Next, we will run the model evaluation job. Here are parameters required by the pipeline. The evaluation dataset to indicate the data location, ID columns to distinguish evaluation examples that are unique, which are ID and document fields in this case. Next is the task. The task we are evaluating is the summarization. And there is the autorator prompt parameters, which is used to configure the behavior of autorator tasks, such as setting the context and instructions. You will then need to provide the response column A and response column B with the names of the columns containing predefined predictions in order to calculate the evaluation metrics. In this case, it is response A and response B. After we define the model evaluation parameters, we can now run the model evaluation pipeline job with this given template using the Vertex AI Python SDK. Let this cell run, as it can take a while for the pipeline to finish. You can click on the link to see the pipeline in action in Google Cloud Platform. So this is how your pipeline looks like. After the pipeline run has completed, you can use the code segment below to view the judgment of each response and how it compares according to the autorator. It offers information such as explanations on the preferences and a confidence score of the autorator. Next, we can also show the aggregated metrics using the code segments below. This is rather useful to determine which model is better in the context of the given task. The autorator also supports human preference to validate the autorator evaluation. We will now use the other URI, which includes an additional human preference column. In the pipeline requirements parameter, we will now include the human preference column and perform the same pipeline run task with the new column of data. We can now obtain the human-aligned aggregated metrics. Again, this is how the pipeline looks like in Google Cloud. Using the code segments below, we obtain the performance of auto side-by-side autorator based on how a human prefers. And lastly, we will clean up the Google Cloud resources. We can run the cell below and it will clean up all of the resources we used in this project. In conclusion, this demo has illustrated the practical applications of auto side-by-side in evaluating the Gemini model on Vertex AI. We've navigated through the setup process, demonstrated how to configure and run the evaluation, and interpreted the comparative results. This hands-on approach ensures you can effectively leverage auto side-by-side to assess and enhance the performance of generative AI models, which in turn helps you make your AI solutions more robust and reliable.